Problem B1. A uniform solid spherical ball starts from rest on a loop track. It rolls without slipping along the track. However, it does not have enough speed to make it to the top of the loop. From what height h would the ball need to start in order to land at point P directly underneath the top of the loop? Express your answer in terms of r, the radius of the loop. Assume that the radius of the ball is very small compared to the radius of the loop and that there are no energy losses due to friction. Solution for problem B1. First, let's write the energy conservation equation. If angle of loss of contact with the track is theta, we can write this equation that total change of potential energy equal to kinetic energy of translational and rotational motion, 1/2 mv square plus 1/2 I omega square. And because motion going without sliding means that omega equal v over r, and also for solid sphere we have moment of inertia I equal 2/5 mr square. And finally we have kinetic energy equal 7/10 mv square. So this is the first relation between angle and v square. Second relation is we can count the moment when this ball leaves the track. This happens when normal force equals 0. In that moment, because ball going by circular motion, we have total centripetal force created by projection of gravity force on the n direction, which is mg cosine theta equal mv square over r. From here we can find what is v square using theta and put in this equation. And now we can count what is relation between height h and angle theta. We have v square equal gr cosine theta, and we can put it here and find that h equal this expression, r multiplied by 1 plus 17/10 cosine theta. Now in a point of break we have Vx equal negative V cosine theta and Vy equal V sine theta. From these two equations we can find what is total time to travel. We have horizontal distance to travel to point P equal negative r sine theta, which is equal to Vx multiplied by time t. And from here we can find what is t. T equal V over r multiplied by sine theta over cosine theta. Next step is to input this time to expression for total vertical displacement. For vertical displacement we have negative r multiplied by 1 plus cosine theta. That must be equal to Vyt minus 1/2 gt square. Time we take from here and put here. And finally this could be simplified to this expression. 1 plus cosine theta equal gr over 2v square sine square theta over cosine theta. But we already have expression for v square over gr, that will be cosine theta, and we could put it here. We have v square over gr equal cosine theta, and we can put it in this equation, and we have this expression for cosine theta. Now we can simplify it because we can cancel 1 plus cosine theta from both sides, and we have a quadratic equation. 2 cosine squared theta equal 1 minus cosine theta, and it has two roots, one negative and one positive. Of course we are interested in the positive. Cosine theta equal 1/2. And now we can put this 1/2 in final expression for h here. And finally we have this answer. When we put 1/2 instead of cosine theta, we have h equal 37/20r. That's the answer for problem B1.